Hi, everybody. I received an email about just some issues with rounding on this R12 set for solving right triangles. So what I'm going to do is I'm probably just going to try two of these examples for you and just talk to you quickly about rounding, because some of you are doing the right things, but you're getting marked wrong for rounding. Now, it is a good lesson to be learned that we want to be accurate. We don't want to round to the incorrect decimals. So here's what we're going to start off with. I'm going to take a look at this example here. As you can see, I skipped ahead and I did a couple examples. So I'm at like score of 73, so I'm up there. So I'm going to take a look at this picture. I'm going to now go find the missing side length. I have two of the sides, so I'm going to use the Pythagorean theorem, which I think is what we should be doing, right? So I just to save some time, here's my Pythagorean theorem. Just to be careful, right? That's your c squared. That's the hypotenuse, so that has to be by itself. So basically, after solving this, and guys, I'm not rounding these decimals. I'm leaving all decimals there. If this had 3 or 4 decimals, I'm leaving them. Even if you wanted to, if you could type in the calculator, you could even type in 9.4 squared minus 8.2 squared and leave the decimals on the calculator. But if you take a look, by the time I get down to it, I have this rough estimate for my side length, and IXL wants us to round to the nearest tenth. So the next number is a 9. I have to use 4.6. So my answer for DF will be for about 4.6 units. Now, the next part is what I wanted you guys to be careful with, because when we're using trigonometry, we're going to get infinite decimals. So what I'm going to do here is I'm just going to back up a little bit. I'm going to put my little stick figure dude here on E. I'm just picking angle E. If you wanted to, you can go find F. So what I'm going to do is I'm going to use E, and I'm going to use these two side lengths. All right, 8.2 is the adjacent side, and 9.4 is the hypotenuse. So adjacent, hypotenuse, I'm choosing cosine. So my equation is going to be cosine of theta, or cosine of angle E, equals 8.2 over 9.4. So now I'm just going to show that step down below. Okay, so here's the equation I just mentioned. Since we're finding an angle measure, we're going to have to use the inverse of cosine. Now, guys, this is the decimal I'm getting for the approximate value of E, right? So it's about 29.2682 degrees. But again, IXL wants us to round to the nearest tenth. So I'm going to go 29.3, okay? So the measure of angle E is 29.3. And while I'm at it, we should know by now that the two acute angles in any right triangle should be complementary, right? They should add up to 90 degrees. So what I'm going to do down the bottom here is, I want you to notice this though, okay? I don't know, I don't want to trust, or make assumptions. So what I wrote here was the measure of angle F equals 90 minus the measure of angle E. Well, we just found E to be 29 and change. Okay, but if you notice, I typed a bunch of these decimals in my calculator just to be sure. I don't want to keep using rounded numbers, because my final answer might be further from the truth. And when I do 90 minus all those decimals, I get about 60.7318, etc. So I'm going to round this to 60.7. Okay, and when I entered those numbers in, I did get the correct score. All right, second example here, guys. Now, if you notice, this one had a couple radicals given to us on the side lengths, which at first looks pretty intimidating, but actually kind of makes the question a little easier, a little less calculator work. So I'm just going to repeat my process here. So from before, guys, I have two sides, and I'm going to use those two sides for my Pythagorean theorem. But if you take a look, if we take radical 29 and square it, we just get 29, which is why I said, makes it a couple steps a little easier. So by the time I get to my answer here, I just have to make sure I read my directions. They want answers written as integers or as decimals rounded to the nearest tenth. Now, an integer would be like 5, -2, 0. So the square root of 14 is not an integer. It's going to be an irrational decimal. So I am going to use my calculator, and I am going to take the square root of 14, guys, which is approximately 3.7, which is why you see that's what answer I'm going to type in a minute. But I want to talk to you right now about rounding. If I put 3.7 here, and I try to use trig with that side, your answer is most likely going to be wrong. I'm not going to say wrong. Your answer is going to be inaccurate. which is probably why some of you are getting marked wrong based on your rounding. You know, I saw the one person who emailed me had like a 9.9 and it should have been a 9.8 or something like that. So what I'm going to say to not do is stay away from, don't use rounded answers in your work. Let's make sure we use the exact answers. So if you wanted to, you could use radical 14 because that contains all of the decimals in it. What I'm going to do is I'm going to just stick to the two sides that they gave me, and just to change things up, I'm going to use theta for this example. So if I want to find the measure of angle G, well, I have adjacent and I have hypotenuse. So once again, I'm going to use cosine. All right, if you wanted to, like I said, you can use radical 14, but I would not use 3.7 because you're going to keep rounding more and more and more in your answer. It's going to get further from the truth. So let's write my cosine equation. It's going to be cosine of theta equals radical 29 over radical 43. Okay, so I did that work just to save some time here. All right, and yeah, you have to type this in your calculator. All right, actually I used the Desmos calculator, and here's what it looked like for me, right? So I do get that 34.7918 and change. So I'm going to come back here, and I'm going to round that to 34.8, okay? And then once again, I'm going to subtract this number from 90 degrees to get my other measure, angle H, and I'm going to make sure that I put them in the right places. Some of you are getting correct answers, but you're putting them in the wrong letter. All right, so then I'm going to head over to IXL. I already put those numbers in here. I'm going to click Submit, and we're happy. All right, so just be careful with your rounding, guys. Let me know if you have any questions.